Oh, hello. Today's Tuesday. Why did the attacking army use acid? To neutralize the enemy's base. I know. Really pretty weak. That's okay. Alright, your tests were due yesterday at 3:15. I will, over the next couple of days, go through those and grade them and send them back to you. Today is Tuesday. We will be introducing the unit on oxidation reduction. Usually we refer to it as redox or redox. So we will introduce it and we will relearn actually, because we've already learned about oxidation numbers. And then I'll assign some of those and we'll do some practice beforehand. As far as this week goes, I know some kids have the AP US History on Friday, so we're going to take it pretty easy on tomorrow and Thursday. Friday I'll put another video together, but you've got the weekend to look at it, so we'll go light. We won't have any homework definitely on Thursday and probably on Wednesday, so you can focus on that. Okay? So, let's take a look. You should have this note packet already. Today, the student will be able to describe what oxidation states or numbers show, explain that there can be no oxidation without reduction, vice versa, and use your CRT to find oxidation states. And finally, assign oxidation numbers. So, this unit is really broken into 3 or 4 main parts. The first part, which you have to have down, this is sequential. You have to know the first part first in order to do well on the rest of it. So the first part is reminding yourself and maybe relearning how to assign oxidation numbers. The second part, it has to do with oxidation reduction reactions. After that, we kind of split it in half, and these we learn about half reactions. And the last part is about different kinds of batteries. Okay, so that's kind of the 3 or 4 main kinds of parts of this particular unit. This is the last unit of the year. We're going to stretch it over about 4 weeks, and then that'll leave us a week to study for your exam, which right now I'm planning to be right about June 15th. Alright, so I'll keep you abreast of that. Okay, oxidation numbers. Now we learned about these when we were learning how to write chemical formulas. So let's recap here. Oxidation numbers or oxidation states, they're numbers to really show how many electrons. How many electrons? There you go. There you go, Aiden. So it has to do with number of electrons an atom will gain or lose depending on which atom it is combining with in the compound. Why do we have to do this? Because we have to honor the law of conservation of energy and therefore mass. Law of conservation of energy says you can't lose energy in any system. Therefore, for every loss, so if we lose an electron, something else has to gain the electron. So we're talking about electrons, and that's essentially energy. Remember, ionic and molecular compounds are electrically neutral. So when we write an ionic substance like sodium chloride, that's a C, this is electrically neutral. Okay? There is no charge here. Same thing with a molecular compound like water. Electrically neutral. So if we looked at the charges here, it would equal 0. Some atoms have multiple oxidation numbers. And what do you do then? Really, you have to find out which of the atom or which atoms, which atom in the compound has the greatest attraction for the electrons. Remember, this is called its electronegativity. If atoms lose electrons, and hopefully remember that in general, metals are going to lose electrons. And if you lose a negative, you become more positive. So they will have positive oxidation numbers. If atoms gain electrons, which is typical of not metals but nonmetals, they will likely have negative oxidation numbers. That should make sense because electrons are negatively charged. Now, as I told you before when we learned this the first time, I will fill in these notes, but it's really practice that will bring it home for you. Okay, so we'll fill these in. The element with the positive oxidation state is written first. And usually, when we learned about it the first time, I described it as the metal is put first. And that's basically true. Unless you've got two nonmetals, okay? Then since you don't have a metal, then the one with the positive has to go first. Now let's take a quick look at our CRT here. Now, you're going to have the ability here to kind of do some cheating. Because this particular periodic table of the elements shows all the different oxidation states. Not all of them, but a lot of them. So, for example, if we go over here to group 1, group 1, every one of them has a positive 1. Group 2 has a positive 2. These are the transition metals. Okay? Transition metals tend to have multiple oxidation states. Not all of them. When we get over here, it gets more predictable. Of course, these, for the most part, are going to have 0, but a couple of them do lose some electrons here, atypical of the noble gases. And these tend to be -1. But you also can see that there are different oxidation states. Look, some of these are actually positive. So because of that, you would have to find out which one of the elements in the compound has more electronegativity. But we'll practice that. So in general, this is going to be -1, this is going to be -2, this is going to be -3. Look at nitrogen. 1, 2, 3. It's got like 7 different oxidation states. So group 1 is always +1. Group 2 is always +2. The free elements, and those are not bound to other different elements, always have an oxidation state of 0. So we've got Hofbrinkel here. These are the diatomic molecules. Okay, all of them have 0 oxidation state. Silver, gold, tin, etc. So when they're not bound. The oxidation state of a monatomic, mon means 1, monatomic ion. So it is an element that has become an ion, and it's by itself. So when you see carbon 2+, you know that it has a +2 oxidation number. When you see chloride ion written as Cl-, you know it has a -1 oxidation number. And oxygen assigned an an oxidation number of -2 in most of its molecular compounds. Most of its molecular compounds. That's a C. Sorry, it's a little messy, but oxidation, -2. So oxygen is pretty much -2. There is an exception in peroxides, like hydrogen peroxides, it is a -1. So you might want to remember that exception. But in general, if you had to guess, 99% of the time, it's going to be -2. Hydrogen, on the other hand, is usually a +1, and we know that because it's up here. But if it is combined with a metal, metals have higher electronegativity than the hydrogen does, and because of that, the hydrogen has a higher electronegativity and pulls the electron away from the metal, and therefore it can be a -1. So when it's with a metal, when hydrogen's with a metal, it has a -1. Okay, and just to remind you, in neutral compounds, it's going to be 0. The sum is going to be 0. Now I just stuck that in there. This is the same thing that you had in the notes from, I think, Unit 3 or 4. You can refer to that if you would like. And the last little bit here is, and this is the one where we have to do a little bit of math, in polyatomic ions. Remember polyatomic ions in Table E? Polyatomic ions, I'm not going to show you because I know it's in Table E, and you know where Table E is in your CRT. For example, phosphate is a PO4 3-. So this is really the figuring out part of it. Let's remind ourselves how this works. So if PO4 is 3-, I've got phosphorus, I've got oxygen. I taught you how to do it this way. So how many atoms do I have? I've got 1 atom, and I don't know what its oxidation state is. That's why I'm putting a blank here in between the parentheses. Oxygen, there are 4 of them. 4. And each one of them is a -2. So 4 times -2 is -8. And my sum has to be a -3. So I just use some quick math. And what number has to go here? It's got to be 5. 5 plus -8 is -3. That means the oxidation state or oxidation number for phosphorus is a +5. Okay? Let's try carbonate. See if I can switch colors. Okay, carbonate is a -1, so I've got carbon and I've got oxygen. How many carbons are there? There's 1. I don't know what its oxidation number is. That's what I'm looking for. Oxygen, there are 3 of them. I know oxygen is a -2 for the most part, so that's a -6. That is my total, -1. So what has to go here? It's got to be 5. So the oxidation number is 5. 5 plus a -6 is a -1. So this is also a +5. Okay? So this is the process that you use for all of them. All right. Now, this goes back to how we name and or write down the chemical formulas for different particles, different compounds. So, let's do one more practice on that, and then we'll do the homework. Magnesium sulfate. So, magnesium sulfate. I'd like you to pause and see if you can come up with magnesium sulfate by yourself. All right, so pause. Okay, we're back. It's magnesium and sulfate. Well, if I look at Table E, I think sulfate is a -2. Let's make sure. Sulfate. Okay, sideways. Sulfate is a -2. Sulfate is a -2. So this whole thing here is a -2. Okay? Magnesium is in group 2, so it has a +2. So if these two oxidation numbers are the same, do you remember what happens? We could crisscross them, just like in this case here, but then they have to be reduced. But if they're the same, they cancel each other out. So this is magnesium sulfate. Okay? All right. Let's look at your homework. I wanted you to do 1, 5, 9, 13. Every fourth one. 1, 5, 9, 13, 17, 21, 25, and 29. All right, so let's do the odds here. Let's do the odds. A couple of them. S and H2SO4. Well, this is a compound and it is neutral. Okay? So, what do I do here? I'm going to take SO4, and I know that's 2-. I just looked it up. I could figure it out doing the neutral thing, but I don't need to. So, I'm taking SO4, 2-. Now, you're going to run into some room here problems, but that's okay. So I'm going to put it over here. So SO4 is 2-. So sulfur and oxygen. Sulfur, I don't know, but I do know that there's 1 atom of sulfur. And I know that there are 4 atoms of oxygen. And oxygen is typically -2, so that makes that a -8. This is my total, -2. So, -8, -2, I've got to have a 6. 6 plus -8 is a -2. So my oxidation state for sulfur here is +6. So that's what you do for every one of them. Okay? Let's try number 4. Well, any atom, actually, I misspoke. So carbon monoxide, CO. This is a neutral compound. I'm going to put this one, I should do the odds over here, but it doesn't really matter. Let's change colors again and make it blue, I guess. Okay, so carbon and carbon monoxide. Let's do it over here. We've got some space. Carbon monoxide. So I've got carbon, I've got oxygen. I've got 1 of each. Oxygen I know is -2. My total here is going to be 0 because there's no charge. Look at the ones that do have charge. That's a -1, that's a -1, -1. Here's a +2. Okay? So if this is -2, this has to be +2. So that means that carbon here and this one is +2. They cancel each other out. All right, let's do one more. H and H2O. All right, hydrogen and oxygen. I've got 2 hydrogens, 1 oxygen. I know oxygen is -2, that's a -2. I also know that my total is 0. So I'm looking for the oxidation state of hydrogen. What does this have to be? -2, this number has to be a +2. 2 times what is a +2? It's a +1. Okay? Okay? So use that logic for the rest of those, please. And then we'll check in tomorrow. All right, have a good day.